Hello everyone, I'm pretty excited to e-meet you all through AWS Reinvent Recap for AWS Budapest Community of Practice. Thanks a lot, Madhu, for your invite. Let me share my screen. This is our agenda for AWS Reinvent Recap. I'm going to talk about Builders Experience, Serverless, and DevOps. Starting with Builders Experience. So what are the things that we're going to see as part of Builders Experience? This section covers the launches that helps the builders build on AWS. We're going to see three exciting things as part of this. The first one is AWS Application Composer. And the second one, Amazon Code Catalyst. And the third one is going to be Amazon Code Whisperer. So first, let's get started with Application Composer. So when we talk about Application Composer, what comes to our mind? Assume if you're new to serverless, you might experience a very steep learning curve when you're trying to compose application using multiple AWS services. First, we need to understand which services you're going to use, how to make them work together, and how to configure the defaults. Certain defaults, how would you configure? So once you have this basic architecture in place, you might want to learn a bit of infrastructure as a code to deploy your application, because building and deploying a cloud-native application is not a one-time job. You have to review, rebuild, and deploy multiple times. For that, infrastructure as a code plays a very crucial role. So with all this, as your application evolves, it's hard to communicate and visualize how the architecture has changed, isn't it? So the AWS Application Composer helps you to visualize and compose, further configure AWS services into serverless applications completely backed by infrastructure as a code. So when we talk about these things, what are the key benefits of AWS Application Composer? One, you can visually compose serverless application using AWS services with very little guesswork. And you can rapidly generate ready to deploy infrastructure as a code that follows the best practices. And you will be able to model the architecture that is easier to share, and your team members can quickly build on that preliminary structure to make a more complex and robust architecture that you need. So, how quickly can you compose this workflow? So all that you have to do is log into AWS Management Console, drag and drop using Visual Editor, and compose it with a little guesswork. And that's it. It simplifies the common tasks. So this Visual Editor accelerates the team collaboration without you have to read hundreds of lines of code and configure them. And also it helps you to translate that visual architecture into deployment-ready configuration that is backed by infrastructure as a code best practices. At the end of the day, what do you want? You wanted to maximize agility while you lower the total cost of ownership, right? Serverless development is the fastest path to take your idea into production. In a nutshell, the AWS Application Composer will help any team further accelerate the path by reducing their learning curve so that they can take the idea into production faster. So next one, so what are the different use cases that you can think of while you're trying to use AWS Application Composer? First one, it is pretty easy to design and build existing serverless applications, or you're going to update the existing applications, right? So let me repeat, it is pretty easy to design and build new serverless applications, or you'll be able to pretty easily update the existing applications. And the second one, you can deploy your serverless application using infrastructure as a code with implementing the best practices predefined by Amazon Web Services. And the third one, you'll be able to visualize your application architecture and configuration pretty easily with the Visual Composer. So how do you get started with the Application Composer? Log into AWS Management Console, begin to draw an architecture of your application. Either you can start a new architecture from the scratch, or you can go ahead and start building by importing an existing infrastructure as a code template and go on. Once you are done, you'll be able to export that template, bring into your own SDK or CI/CD, and then execute it. Right? Next one, Amazon Code Catalyst. So Amazon Code Catalyst is the unified software development service that makes it faster to build and deliver software on AWS. For any software development team to provide a seamless delivery to production, the teams need to spend significant time and resources on collaborating effectively, setting up the tools that is needed, setting up the development and deployment environment that is required, and configuring the continuous integration and continuous delivery automation, isn't it? So Amazon Code Catalyst is here to enrich your development with an integrated product experience. By bringing in the tools that is needed, you can plan, code, build, test, and deploy your applications to AWS, all in one Amazon Code Catalyst integrated experience. So how would you use that? You can use Code Catalyst to browse and choose from the collection of existing blueprints, or you can create something new. So with this, you'll be able to set up CI/CD workflows to run the managed build infrastructure, or you can define the architecture and configuration of AWS services used by the project. So we say that by using Amazon Code Catalyst, you'll be able to bring in the issue tracker by default, the source control system by default. But what if you wanted to use your pre-existing GitHub, not the one which gets generated as part of Amazon Code Catalyst? Yes, you'll be able to configure it by going to use the GitHub repository that you want to integrate with this Amazon Code Catalyst. So that is pretty simple. You can also use the source control of your choice as well. So as of now, Amazon Code Catalyst is available in preview today in US-based Oregon region, and it is available only in US-based Oregon region. But you know what? You can automate the deployments to any AWS account or to any AWS region just by spinning up the Amazon Code Catalyst, which is available in US-based Oregon region. So that's about Code Catalyst. So how do you get started? So here, with respect to Code Catalyst, you'll be able to spend more time in coding and less time in managing the entire development environments. So to start fresh, what you can do is you can go ahead and use the pre-configured dev environments, which is available on demand. And you'll be able to share this environment definition with your whole team. And if you need to make any changes to this definition, that definition is available immediately to the entire team with less effort. And this dev environment will let you use your favorite IDE from any device, and you can develop from anywhere. So as of now, you can create this dev environment either from the Code Catalyst, or you can create it from any one of these favorite IDEs: AWS Cloud9, IntelliJ IDEA, Visual Studio Code, PyCharm, and Golang. So you can use any of this. And when you create the projects or the environments with Code Catalyst, you might have multiple projects, right? You'll be able to switch between the projects or repositories or branches just with one click. You might wonder, not one size that fits everybody. Each one might want to have the development environments in different size of their choice. So the dev environment here is available with 4 different compute capacity as small, medium, large, and extra large. So you are free to create something of your own choice and you will be able to use it. Okay, so here, as far as the development environments are concerned, you're not limited by the power of your personal machine, your laptop or desktop. You can launch a dev environment with the compute capacity and the memory or storage that is required for you to be more efficient and work faster. So that's about Amazon Code Catalyst. The next thing that we are going to look into is Amazon Code Whisperer. Amazon Code Whisperer is a machine learning powered service that helps you improve developer productivity by generating code recommendations based on the developer comments. All that you have to do is log into this IDE, get into this IDE, type your comments in your natural language, and the code corresponding to that IDE gets generated in the IDE itself. So all that you do is add comments in your natural language and you will see the code suggestions. These code suggestions are available both for your AWS services and as well as code. So how simple is this? When writing code, developers must keep up with multiple programming languages, frameworks, software libraries, and popular cloud services, right? So with Code Whisperer, by simply writing a command in the IDE's code editor, the Code Whisperer automatically analyzes the command and it determines us that which cloud services or the public libraries are best suited for a specified task. So you can create this code services very quickly. So that's about Code Whisperer. And one thing is, the Code Whisperer now provides AWS administrators the ability to help their organization use single sign-on authentication so that the administrators will be able to easily integrate their Code Whisperer with the existing workforce. You don't have to specify or configure any other access criteria for the corporate users. And the individuals who do not want to have AWS account can also use Code Whisperer. That's the best thing. See, because to use every other AWS service, what you'll have to do is you need to go ahead and create an AWS account and then use it. So as an exemption with Code Whisperers, what you can do is by using AWS Builder ID, you will be able to use Code Whisperer even without an AWS account. And the sign-in process takes a very few minutes and which can easily enable developers to start using Code Whisperer immediately. And you know what? The Code Whisperer, initially it was launched with specific languages. Now it has got added Python, Java, JavaScript to its list, right? So this continues. There's a small correction here. Earlier, it launched with Python, Java, and JavaScript. And now developers can use C# and TypeScript as well. And this Code Whisperer is available in multiple IDEs, similar to what we spoke about Code Catalyst, right? So here also a bunch of IDEs are available or integrated for us to use this toolkit. One is Visual Studio Code, JetBrains, AWS Cloud9, AWS Lambda. From all these IDEs, you'll be able to use Code Whisperer to develop that is required for you. Okay. So the other thing that I wanted to add from Code Whisperer is I wanted to reiterate upon this, even if you do not have an AWS account or you do not want to create an AWS account, using the AWS Builder ID, you'll be able to use Code Whisperer. Okay. So now, whatever we spoke, right, the three stuffs under Builder's Experience. The first one, Amazon Application Explorer, Application Composer, Code Whisperer, and Code Catalyst. All these things are in preview. Go ahead and explore and wait for GA so that we can start using the production scale. And the next, let's move on to serverless. So when we talk about serverless, the first thing that comes to our mind even today is AWS Lambda, isn't it? AWS Lambda is the backbone of serverless development. Since 2014, we have launched over 100 new features for Lambda. And at present, with over 1 million active customers using that, with 10 trillion requests per month, Lambda is one of the best known AWS serverless service. And today we're going to talk about one of the new feature that got added to Lambda. So we all know that Lambda provides a simple programming model, which is easy to integrate with other AWS services while being able to create apps that can quickly adapt to changing usage patterns. So in many cases, what happens is the execution of Lambda function takes milliseconds to begin. In other cases, this init phase, which we are going to look in next slide, it's going to take a little longer due to various number of reasons. And some unique cases in Java runtimes and use cases, this takes a little longer, which we call it as, or which we term it as cold start. So how do you prevent cold start is what the AWS Lambda snapshot feature is going to be. Currently, this particular feature is available for Lambda functions which are developed using Java with version corresponds to Java 11 runtime. So how this is going to work? So this cold start, when you enable for a Lambda function, it is going to reduce the initialization time by 90%. This is going to cache the Lambda function and keep it in the memory, and it is available for you to use. Remember that these cached snap starts will be removed after 14 days if it is going to be inactive. And most important thing to note here is there is no additional charge for using the Lambda snapshot. Okay, so it is basically recommended for your general purpose Lambda functions. Now we'll see life cycle of AWS Lambda snapshot. So how would you use this? When we look into it here, the first thing you see the implementation or the life cycle of a Lambda without snapshot enabled. The life cycle from init, when it is creating the execution environment, downloading the code, starting the runtime, all of this falls under AWS category of optimization. And the second category of initialization is customer optimization. For anything, there is equal responsibility that AWS owns and customer owns, right? So all of these things falls into a cold start, which takes several seconds. After that, only the Lambda handler is invoked and that does the actual functionality. Now, when the snapshot is enabled, the life cycle, what happens within the snapshot is it's going to invoke. No, when this particular snapshot is enabled, there are three things that happens within the life cycle. First thing is init, invoke, and shutdown. So what happens during this initialization phase? When the snapshot is enabled for the newer version, it's going to publish the newer version of that function. And the process will launch the function and run through the entire init phase. Remember, it's just going to launch the function, run through the entire init phase. And this particular function, which is immutable, it is encrypted and it is stored as a snapshot with the memory and the disk state for you to use. This is basically is cached for you to reuse it at a later. Now, whenever the function is invoked, this state is going to be retrieved from the cache. This completely removes where we need to go through the entire full init phase whenever it is invoked, right? So thus it solves the cold start issue. And with this functionality is now enabled for Java functions, which is going to make it 10 times faster than the regular Lambda function, That is, the init state's performance is increased by 10%, 10 times, at definitely no extra cost. Now, one thing will come to everybody's mind, right? How different is this Lambda snapshot from the provision concurrency? So we know that provision concurrency has been in use for quite some time. What is that being used for? The provision concurrency basically keeps the functions initialized and ready to respond in double-digit milliseconds. That's a key thing, right? Here, when Snapstart is enabled, it's going to help improve the startup performance by up to 100%, 100x speed at no extra cost. So one thing which you have to keep in mind is a certain feature compatibility requirement. That is, you can't use both Snapstart and provision concurrency on the same function version. That is the key requirement. So that's about AWS Snapstart lifecycle. Next thing that we are going to see is Amazon Event Bridge Pipes. A new feature of Amazon Event Bridge is that it's going to make it easier for you to build event-driven applications by providing very simple, consistent, and cost-effective way to create that point-to-point integration between the producers and consumers by completely removing the undifferentiated coding that you'll have to do. Usually when you're trying to do, you'll have to make some coding which will enable that communication between the event producers and consumers interact. So this pipes is going to take away that undifferentiated heavy lifting from your shoulders and you'll be able to do it. So when you're trying to do this, right, when you see in this diagram, you have a source, the filtering option, enrichment option, and target. The source is where the events get generated and it's coming. The sources from different means. It includes your DynamoDB, Kinesis, or SQS. And the first optional one is filtering. Here you can define the patterns, that is from what source this event can be allowed to pass through this event point. That is the first filtering option you can specify on the source side. And before it goes to the target, you might want it to transform that event, enrich that event by using either Lambda or by stub functions or even API. You can apply that enrichment, which is also optional, before it reaches the target. So even Bridge Pipe is a cost-effective way to provide a point-to-point integration between your producer and consumer. So with Amazon Event Bridge Pipe, you can integrate supported AWS and self-managed services as event producers and event consumers into a simple, reliable, and cost-effective way. The next one, what we are going to see is distributed map for AWS step functions. So there is a new distributed map state which has been introduced that will allow you to write the step functions to coordinate between the large-scale parallel workloads with your serverless applications. So you can now iterate over millions of objects such as log files, images, CSV files that are stored in S3 bucket. So what you can do with this distributed map is the distributed map state can launch up to 10,000 parallel workflows to process the data. It's not a small number, right? You can process the data by composing any service API supported by this step functions. But typically what you will do is you'll invoke the Lambda functions to process the data with code written in your favorite programming languages. So during execution, you can also consider downstream service capabilities. That is, when you're processing a very large set that might not fit into a Lambda temporary storage and memory. So that's when you would go for using this downstream service capabilities. And you also have the flexibilities to choose which service to use. For example, in my mental model, the data scientists and data engineers, they can use AWS Glue and EMR to process large amounts of data. On the other hand, application developers will use step functions to add serverless data into their applications. So you can actually pick and choose what would best fit your need. Now, so with this, what I want to say is the step function is able to scale from zero very quickly, and it will definitely make a good fit for interactive workloads where the customers may be waiting for results. So it's the best use case and it will be very effective for interactive workloads. And the next one is Amazon App-Flow supports lots of applications right now. So we know this App-Flow is not something new. It got introduced earlier, which is available in functioning for quite some time. So this App-Flow allows customers now to realize full value of data, which is spread across enterprise SaaS applications. So it is basically a low-code, no-code solution with just, you're going to point and clicking the UI, you can make this interface up and running and serve that is needed. It acts as a better connector and to transform data or move data from your SaaS applications to any of the services. You can basically establish the connection between the application as needed. So there are 50 plus such applications or services that are getting supported as part of this launch. So what you can do is, with this, you can apply transformations such as mapping, merging, masking, filtering, and validations. And you can build your own connector as well using AWS SDK. Basically, it's easy to build to securely transfer data between your custom endpoint or your application or between your AWS cloud services. You can actually use these connectors to transfer data or exchange data between the cloud services to and from AWS or the applications hosted on AWS in different ways. So what you see on the screen is the whole bunch of support that got newly introduced. If you see marketing connectors, it is available for Facebook ads, Google ads, Instagram ads, LinkedIn ads, all of that. And when we are working in a corporate world, we tend to use a lot of meeting options. Could be the Teams, your Zoom meetings, all of that. So name it any stream. So you have these connectors available now with this Amazon App-Flow. So now we have gone through Builders Experience and we have seen these launches or the new features that got launched as part of Serverless. And now we are moving to the third section that I wanted to discuss. So in the third section, it's DevOps, my favorite too. So we are going to see what are the new launches in DevOps. So in this section, we are going to explain the launches that covers resiliency, deployments, and observability. The first and foremost is AWS Amazon ECS Service Connect. So monolithic to microservices, it has been a story of discussion everywhere and anywhere, right? The microservices architecture are well-known software development approach, which is composed of small independent services that communicate over well-defined APIs. So what happens here is the customers most of the time face challenges when they're trying to establish that communication or that networking between these microservices. How would you enable these microservices communicate internally with each other? That is one of the customer's challenge. So this ECS Service Connect comes in to rescue the customers from that challenge of establishing the specialized networking connection. They need not have that specialized networking knowledge to enable these microservices interact with each other. So when you say ECS Service Connect, it provides an easy network setup and a seamless communication deployed across multiple ECS clusters and VPCs. So what you can do is, with this, service. So as you see in the diagram, you have AWS Cloud Map, you have ECS cluster, and in between comes the ECS Service Connect. So with Cloud Map, you can actually use this Cloud Map as a service discovery. If you're going to use the third-party stuff, you will have to have all the effort involved in dealing with the infrastructure, configuration, all of that. But when you use AWS Cloud Map, it's a managed services provided by AWS, pre-built with all the configuration and functionalities and ready to use. So with ECS Service Connect, you can refer and connect your services by using the logical names which are provided by AWS Cloud Map. These logical names are provided as namespace in the AWS Cloud Map, and these namespaces automatically distribute the traffic between the ECS tasks without deploying or configuring the additional load balancers. So that's how easily it facilitates the connection and communication between the deployed ECS tasks. And you can sometimes set the defaults for traffic resilience. You can include health checks. You can also configure for automatic retries. For example, if there is a 503 error which comes up, you can configure for automatic health checks and automatic retries when such errors, and then it moves forward, right? That's how you can define to build resiliency against this traffic. And you can also configure connection draining for your ECS services. So this is how you would use the AWS ECS Connect. And also, additionally, in AWS Console, it provides easy to use dashboards with which you can actually monitor this network traffic for your operational convenience and also for more simplified debugging. So that's about AWS ECS Service Connect. Next, we are going to talk about is Amazon RDS Blue-Green deployment. So with this RDS Blue-Green deployment, it's a new feature which comes up with Amazon Aurora with MySQL compatibility, Amazon RDS for MySQL, and Amazon RDS for MariaDB. For all these three variants, this RDS Blue-Green deployment is newly launched, and this is going to make the database update or software update much easier, safer, and simpler and faster as well. So how does this work? With very few steps, you can set up Blue-Green deployments to create a separate environment. What you do, the first step is you will build the staging environment. So in this staging environment, this is going to clone your production environment's primary database and also the in-region read replicas. Once you initiate this staging environment setup, the Blue-Green deployment automatically keeps these two environments safe by syncing both the replications, right? So whenever any update or write happens to your production environment, the write also happens to the staging environment. So now, within as fast as less than a minute, you will be able to promote this staging environment to your production environment. At this point in time, during switchover, what you would do is you're going to promote this green environment, which is your staging environment, to your production environment. So the deployment blocks writes on both blue and green environments so that the green catches with the blue, ensuring there is no data loss. So one thing what happens here is this particular Blue-Green deploy, it is actually helping to make your software changes. It could be your major or minor upgrade to the software or schema modifications or operating system changes or any maintenance to seamlessly apply to the staging environment without impacting your production load. Because we know that the data gets replicated both to the staging environment and production environment. There is no loss. And the switchover can happen within less than a minute. So during the switchover, the staging environment becomes your production environment and it starts working, right? So the Blue-Green deployment simplifies your switch or upgrade all that with a seamless effort. Okay. So now let's look into AWS Elastic Disaster Recovery, automated failback. So when we talk about this Elastic Disaster Recovery, it enables customers to use AWS as an elastic recovery site for an on-premise application without needing to invest on-premise DR infrastructure. So the most important challenge that we have in the data center world is that we have to spend lots of money in bringing in disaster recovery infrastructure, which will be used only very rarely. So this elastic disaster recovery, automated failback, or this disaster recovery setup as such, it will enable the customer that there is no need to have a specific infrastructure built and kept idle all the time on premise. And this can be done directly on cloud. It's all about that. So once you enable this DRS, disaster recovery setup, it maintains a constant replication posture for your operating system or applications or database, anything that is running on the AWS cloud. So this is not something new, this elastic disaster recovery, which is already in place. So what got introduced now is in AWS failback. So that is in a non-disruptive way, how you could fail back and create an EC2 instance in a recovery mode. So if you see in this particular, this is a flow. So it installs the replication agent and the DRS, it gets failover, it is available, ready, that is as a B1. And once the recovery is initiated, the recovery instance created, this failover is complete. Now the instance is ready. Now the failback started. That is, you wanted to take this particular recovered EC2 instance and put it on the source original region and make it available and ready to serve the traffic as is. So during the process, you might create several instances in between, either as a recovery instances or recovered instances. So after all that, you will be left only with the instance that is required, and the rest all the things can be cleaned up. So it starts with the step of installing the agent, and it starts the failover process. You're going to initiate this recovery from B1. If you see, the recovered instance is B2 and the instance recovered is B3. So we are good, right? I'm repeating it. We are going to initiate the failback process. Once you initiate, this DRS A2 is ready. This is the recovered instance. And finally, the launched one. After the one which is going to serve the traffic is launched, the rest all is cleaned up as part of the cleanup effort. So this failback is something which got newly introduced as part of AWS reInvent 2022. So that's about disaster recovery. And as far as AWS backup is concerned, consistently new features gets introduced. And what got supported this time is backup for Amazon S3. It's in public preview. And the rest of things are GA, the support for VM workloads. You can protect and restore your CloudFormation stacks. That is a very interesting thing. So these are some of the new features which got introduced as part of AWS backup. And the next one is CloudWatch Internet. So this is a quite interesting thing. It's a new capability of CloudWatch that gives visibility into how an internet issue might impact the performance and availability of our applications. So basically, this is not something out of the blue. Amazon have started using the existing networking footprint, what they use is for their own AWS infrastructure and stuff. It has been reused for monitoring our internet uptime and availability so that we can clearly see where the issue is, right? So with this internet monitor, you can gain a complete awareness of the problems that arise on the internet experienced by the end users in different geographical locations and networks. So you'll be able to easily visualize what is happening for your customer without keeping them in dark. So this dashboard is pretty cool. So you have a monitoring dashboard. It provides a visibility whenever there is an internet issue. So all that you know is what happens within your area, right? So since AWS is pervasive across geographies with different regions and availability zones, leveraging and using their own internet and related capabilities, they're able to, or AWS is able to help us monitor how the internet issues can impact our customers globally. So this is a very interesting one. And the next one is Amazon CloudWatch logs data protection. So the data protection in Amazon CloudWatch logs is a new set of capabilities which leverages the pattern matching and machine learning capabilities to detect and protect the sensitive data which you're logging. Basically, so how do you enable that? So with this, you log into AWS Management Console, select a specific log group. For example, if you've configured a log group for your Lambda function, go to that log group. You have a new tab called Data Protection. Go and select that. Now in this tab, you're going to pick up the identifier. For example, it could be a date of birth or email address. If such information passes through this log, that gets masked. And the next one is you're going to choose your destination where this audit report has to be stored, whether it could be another CloudWatch log group, or it could be an S3 bucket, or you can even create an alarm around this metric, right? So you can configure this. So once you have configured the data, when it passes through, if it checks the email address or date of birth, it's going to mask and store it. Remember one thing, once it is masked, the downstream services that are going to consume this will not be able to fetch the unmasked information. So it doesn't mean that you cannot unmask the data, but the users with elevated privileges with an IAM policy will be able to unmask the data in the CloudWatch logs insights. So with all this, you can also have GetLog Events API configured, which can fetch you the unmasked data to be processed by the downstream events as well. So that's how you can configure and use this Amazon CloudWatch logs data protection. So the next one is Amazon S3 multi-region access point failover control. So this multi-region access point was launched in September 2021. What happens with this is it gives a global endpoint that spans S3 buckets in multiple AWS regions. So with S3 multi-region access points, you can build applications with the same simple architecture that you're using in single region by facilitating multiple regions. So how does this work? So assume you have created a S3 multi-region access point with S3 buckets in 6 different regions in Asia Pacific. It could be Tokyo, Mumbai, Singapore, all of that. So once you have configured and created this, you can go ahead and configure Tokyo as an active one serving the traffic, and the remaining as a passive multi-region access point configuration. So what got introduced now is failover. How would you failover? So once you have configured Tokyo as an active region, Singapore, Mumbai, and rest of the Asia Pacific region as a passive one, now the traffic is being served from Tokyo. So by default, the multi-region access point routes the traffic to all of the buckets, right? So now once you have configured, this will start serving to Tokyo. Now, what if there is a failure that is happening in the Tokyo region? Assume there is an unforeseen issue that Godzilla have eaten up all the underwater cables for Tokyo region. So that region is down. That's not going to serve the traffic. So you see a failover. What you will do is go to the replication tab. In the replication tab, now with this particular new feature, you have replication and failover added. So when the failover is there, what you would do is you would go ahead and configure another region, for example, Singapore as an active region, and make Tokyo as passive one. So the traffic will go get served from Singapore region. Your system is up and running. Now, if the Godzilla have subdued, if it's all back on track, what you will do is you can go ahead and fail back to Tokyo. So if you see closely, this failover and failback is what got introduced as part of this AWS reInvent 2022. So that's about Amazon S3 multi-region access point failover controls. So this is available in the replication tab. Along with that replication, you see a failback thing got added. And the last one for today, what we have is Amazon Route 53 ARC zonal shift. So this zonal shift is a capability that is built into ELBs and is exposed via R53 ARC controller. So what it does basically, it allows you to shift the traffic for a particular availability zone, which might be experiencing higher latency. So with this, when you're experiencing higher latency and you wanted to move the traffic to a healthy availability zone elastic load balancer nodes. So that is what is the zonal shift is all about. It is basically we call it as a recovery oriented strategy because it's going to allow you to recover your application very quickly before even you start attempting to investigate the root cause because of the increased latency. So what is more important when there is a you're experiencing a higher latency, your intention is to serve your customer with a better experience and parallelly investigate the root cause. So this particular zonal shift provides you with that capability. Now that you have an opportunity, you'll be able to move traffic towards the healthy availability zones with increased results to the end user. Right. So this zonal shift is designed to be a temporary fix. Okay, this may not be the permanent solution, but it's a temporary fix where you can focus your investigation while your customer is not interrupted with their traffic that is needed. Okay, so with this, my sharing has come to an end where we spoke about builders experience, serverless, and DevOps. Now all that is back to Madhu. Looking forward to be in person one day in Budapest, the majestic city with the aquatic heart. Thank you so much. Wish you all a very great learning. Thanks a lot.